So in this part of our lesson, we're going to be talking about combinations of functions. Basically, this just means this is different ways we can take two functions and we can add, subtract, multiply, and divide them maybe to make new functions. There's different ways that you can write combinations. There's kind of a way that makes sense in my opinion. So here's an example. You could say, let's take f of x and let's add g of x. That might be one way notation could be written. Or you might see it written like this, which I feel like is so bizarre looking. But this is another way to write the exact same thing. So I just want you to be familiar with both different setups because you'll see both in your textbook. And even on AP questions, they tend to kind of go back and forth between these two different notation styles. So make sure that you are okay with both. So there would be the multiplication and then division would look something like this. Okay. All right, so when you are composing a function, it's just a way of taking one function and plugging it into another. So let me go back real quick. This would be a combination of functions, literally combining two to make something new. This is a composition. A composition is taking one and plugging it into another, not adding two together, but literally taking an equation and plugging it in to another to make something brand new. So let me show you an example of what that is. What we're going to do is we're going to use the equation f of x and g of x shown here, and we are going to find f composed with g. That's how you would say that. Another notation way to do this, or write this, would be f of g of x. Those are both written right here. So we're going to do that. That means we are going to be taking g of x and plugging it in to the f equation. Same meaning over here. You take the second thing and plug it in to the first thing. So I'm going to take g of x, which is x squared plus 1, and plug it in to the other equation for x. Okay, so f composed with g, also known as f of g of x, would be equal to x squared plus 1 going in to the other equation in place of x. There's your answer. It would be radical x squared plus 1. You can also compose things the opposite direction. So I could do g composed with f. Let me show you what that looks like. So g composed with f, or g of f of x, another way to say it, would be the opposite direction. So it would be taking the radical x and plugging that in to the x in the other equation. So it would be radical x squared plus 1. And that one could be simplified because square root of x, quantity squared, would just be x plus 1. Let's do a couple more examples. So we are finding f of g and then g of f, which means f composed with g, and then later we will do g composed with f. So you always take the second thing and plug it in to the first thing. So g of x plugged in to the f equation would be f composed with g. So that means x minus 3 is going in place of x. Squared will remain, and then we could simplify if needed. This would be x squared minus 6x plus 9. Okay? Other direction, we're going to take f and plug that into g. So f plugged into g would be x squared minus 3, and that can't be simplified any further. Okay? One quick note. Just because you did f composed with g and g composed with f, and just because they look like they're similar, does not mean that they are the same. Obviously, here's Exhibit A. f of g, or f composed with g, I got x squared minus 6x plus 9. But when I flipped it into g of f, I only got x squared minus 3. So it's not the same thing. Order does matter. Here's an example of just more of the same thing. I don't really want to go to f composed with g or g composed with f. I'm going to skip these two, and I'm going to focus on the ones that I think are a little challenging, and that's f composed with f and g composed with g. So here's what this means. This means I'm literally going to take equation f and plug that same thing into itself, kind of. So it might help to say, well, what's equation f? It's radical x, and this one's also radical x. I'm plugging radical x into the radical x equation. So that's going to look like you have a radical, and then you're plugging a radical into a radical, if that makes sense. It's weird, but what that would become is it would actually become x to the 1/4 power, which is the same as the 4th root of x. The reason for that is if you're square rooting something twice, it's the same as taking the 4th root, okay? So that would be your answer. For D, same thing, but you're doing that with radical 2 minus x, and you're plugging it into radical 2 minus x. So all this is going to go in place of the x there. So you're going to have radical 2 minus, and here's where you plug in your other equation. And that can't be simplified at all because that is just a big old mess. So you are done there. Okay, so the last thing we're going to do here is we're going to undo a composition. So basically, you have an equation f of x, and it was created by composing something 3 times. So there was an f, there was a g, and there was an h. I want you to undo that, okay? I want you to undo that. So, I need to figure out what f, what g, and what h would have been if I took h and plugged it into g, and took all of that and plugged it into f, and ended with this function, okay? So what I do is I usually tell my students to start on the inside, the very most inside thing in this equation, and that would be what was plugged in first. So the inside to me would be x plus 9, so we're going to call that h. And then you kind of work your way through. The next thing that would have been plugged in would be cos, because the very last thing that would have been computed was squared, okay? This is kind of a hard skill to teach because it's more of like a puzzle or a guess and check thing. So I am going to prove to you that this would work by doing the composition using these 3 functions that I just came up with. So if I take h and plug it in to g, I would get cos of x plus 9. So that all looks good. And then I'm going to take all of that and I'm going to plug it into f, which is x squared. So I would get cos of x plus 9 quantity squared, which doesn't look exactly the same as the example that was given. However, when you have trigonometry, you're allowed to move the squared over to this trig function and write it like cos squared, like this. So that means we do end up with the same thing.